Everyone, welcome. Today, we're going to take a journey, an incredible one, through our planet's underwater worlds. We're going to follow the water from tiny inland streams all the way down to the crushing darkness of the deep sea, and along the way, we'll figure out how life really works beneath the surface.
It's kind of a funny thought, isn't it? We call our home planet Earth, but it's really a water planet. Almost 3/4 of it is covered in this stuff. And for as much as we know about the land, what's going on under the water is often a huge mystery. So let's try and tackle that big question. What is life really like down there?
So, before we dive in, pun intended, we need to get a handle on the basic rules of the road. These are the fundamentals that apply everywhere, whether you're in a little pond or the deepest part of the ocean. Think of it like learning the physics of the underwater universe.
Okay, so rule number 1, and this is the big one. It's all about light. The top layer of any body of water is called the photic zone. The photo part is just like in photography. It means light. This is where the sunlight can actually penetrate, and because of that, it's the engine room for most aquatic life. This is where photosynthesis can happen.
But once you go deep enough that the sunlight can't reach, you enter a totally different world, the aphotic zone. Aphotic literally means no light. Down here, it is permanent, pitch-black darkness. Photosynthesis is completely impossible, so life has to get really creative to find energy.
And you know, life isn't just floating around in the middle of the water. Down on the bottom, whether it's a rocky riverbed or the mucky floor of the deep sea, that's the benthic zone. And the critters that live there are called the benthos. We're talking about everything from crabs and sea stars scuttling around to tiny worms burrowing deep in the mud.
So you can see this creates a huge split, right? Up in the photic zone, you've got sunlight as the fuel, kicking everything off with phytoplankton. But down in the aphotic zone, it's a whole other game. In that total darkness, life has to depend on other sources of energy, like stuff falling from the world above.
And here's how it all gets started at the very, very beginning of the food web. In that sunny photic zone, you have these microscopic algae called phytoplankton. They're basically tiny floating plants. Then you have zooplankton, tiny little animals that come along and munch on the phytoplankton. This simple little dance, this two-step process, is the foundation for pretty much all life in the sea.
All right, now that we've got the basics down, our real journey can begin. And we're going to start inland with the freshwater ecosystems, following the water as it starts its long trip to the sea.
So when we talk about freshwater, it really boils down to 3 main categories. First, you've got the moving waters, your rivers and streams. Then you have the still waters, like lakes and ponds. And finally, you have these incredibly rich and important areas called freshwater wetlands, things like marshes and swamps.
You know, let's just take a second to talk about wetlands, because they are so important. They're like nature's giant kidneys, filtering out pollutants and cleaning the water. Plus, they act like massive sponges, soaking up excess water and preventing floods. They really are ecological superheroes. Okay, so our river journey continues, and as that fresh water flows toward the ocean, it hits this amazing, super important transition zone, a place where 2 worlds collide. And that mixing zone? We call that an estuary. It's a special kind of wetland where all that fresh water coming down the river finally meets and mixes with the salt water from the ocean. It creates this unique brackish water that's always changing with the tides. So why are estuaries such a big deal? Well, for starters, they're shallow, so sunlight can reach all the way to the bottom, which means tons of photosynthesis and tons of life. They're basically nurseries for the ocean, critical for a lot of the fish and shellfish we depend on. Just think of the huge salt marshes in Chesapeake Bay or the amazing mangrove swamps down in the Florida Everglades. All right, we've made it to the coast. We're leaving the freshwater behind and heading out into the vast, salty world of marine ecosystems. Our exploration starts right here at the ocean's edge.
Okay, so check this out. This is basically our roadmap for the rest of the trip. You can see how scientists break up the ocean into different zones based on 2 things, how deep you are and how far you are from the shore. We'll use this to guide us as we head out into the blue.
Our very first stop is the intertidal zone. If you've ever been to the beach and explored tide pools, you've been here. It is a world of extremes. One minute it's underwater, the next it's exposed to the hot sun and air. The creatures here, like barnacles and seaweed, have to be seriously tough to survive the constant pounding of the waves.
Okay, let's wade out a little further, past the crashing waves, to the coastal ocean. This is the brighter, shallower water that sits over the continental shelf. Because it gets plenty of sun and lots of nutrients washing off the land, it's super productive. This is where you find those incredible, towering kelp forests and, of course, vibrant coral reefs.
And now for the big leap. We're heading past the continental shelf and out into the open ocean. And this is the big one. This part of the ocean makes up more than 90% of the world's total ocean area. We are venturing out into the vast, open blue.
Now, you might look at the sunlit surface of the open ocean and think, wow, it looks kind of like a big blue desert. And it's true, the nutrient levels here are pretty low. But here's the mind-blowing part. Because this zone is so unbelievably huge, just its sheer size means that this is where most of the photosynthesis for our entire planet happens, right here.
Okay, you might want to take a deep breath for this next part. We are leaving the sunlight behind. We are now descending into the permanent, total darkness of the Aquatic zone.
I mean, the conditions down here are just extreme. You've got crushing high pressure that would flatten a person in an instant. The temperatures are just barely above freezing. And of course, there is absolute, complete, total darkness.
You know, for the longest time, scientists looked at those conditions and thought, there's just no way. They figured the deep sea floor had to be a barren wasteland, almost completely empty.
But they were totally wrong. In the 1970s, something happened that completely flipped biology on its head. Scientists discovered these amazing spots on the seafloor called deep sea vents, and around them were these incredible islands of productivity, absolutely teeming with bizarre and wonderful creatures. And the secret sauce here, the key to all this life, is a process called chemosynthesis. Instead of using sunlight for energy, the bacteria here use chemicals spewing from the Earth's crust. They form the base of an entire food web that has never seen a single ray of sunlight. So that leaves us with one final, huge thought. If life can find a way to thrive in total darkness and under crushing pressure, right here on our own planet, it really makes you wonder, doesn't it? Where else out there in the universe might we find